The system is changed. I feel it in the backlog. I feel it in the design. I smell it in the pull requests. Much that once was is legacy, for none now code who remember it. It began with the forging of the great services to manage ship cruising. 3 business domains were given to the search team. Everlasting, marvelously straightforward, and certainly the first pioneers, at least in their own esteemed opinion. 7 to the post-booking team, trend seekers, wise admirers, and devoted followers of fleeting glory. And 9 domains were given to the modernization task force, who above all else desired power. For within these domains was bound the strength and the will to govern each value stream. But they were all of them deceived, for a universal ubiquitous language was made. High in his ivory tower, in the fires of Mount Togath, the lead architect Sauron forged a master model. And into this model he poured his compulsion for control, his obsession with uniformity, and his will to standardize all life. One model to rule them all, one model to shape them, one model to bring them all, and in the big ball of mud bind them, in the land of design dead, where the shadows lie.
Well, I finally finished adapting my model to fix this bug. Now travelers can book their ship cruises without having to bother with past departure getting in the way. Although that was quite complex, and it took way longer than I expected. Maybe I should have stepped back. I think we're missing some sound.
Clearly, this was the right solution. Yes.
The new model is great. Let's ship that in production.
The monitoring dashboard shows a critical regression on the booking history feature.
I didn't touch that feature. My change was completely unrelated.
We are quite sure the problem comes from your last deployment. Let's review the response of your API together.
It's just this.
OK. I didn't realize the model has grown that much. Last time I checked, you were handling the search, and the model was quite clear. But now it's a total mess. Look, you just done the selection and the booking concern in your search model.
No, I didn't dump anything in it. I did things right. I'm always doing model exploration before implementing a feature.
And what's your process?
That's easy. So I always start from the business needs. So in the case of our MVP, it was to search ship cruises. This drives an exploration and experimentation phase, which which in turn shapes the model. Now, once I have this, my model needs to take into account for new business needs. So in the first iteration, we had the ability to select ship cruises, which drives another event storming and so on, which shapes modification to the model to account for these needs. Then we account for new needs again, and so on, you know, basic stuff. So model exploration whirlpool.
But it's not model exploration whirlpool what you have done. You were continuously stacking changing in your first model, which introduced coupling, and eventually it became a big ball of mud.
A big ball of mud, that's too much.
No, I mean, here, your model exploration whirlpool turned into model thinking.
No, precious. We refined this model, yes. Refines it lots. We can still adapt it, precious.
No, this is not a big ball of mud. It's only a bug, and I can fix it. There you go.
But you just broke the See Previous Days feature, which allows users to check earlier departure for cheaper options.
I can fix that too. There.
But your fix is not even sufficient. You don't fully address the problem.
OK, I can fix that too.
But stop. You updated half of your model. Can't you see here that amount of code you change? It's a nightmare. 90% of the tests as well have been changed. So can't you see it's a total mess, a big ball of mud full of coupling? So given all the change you've made, do you still understand what's happening in your model?
You're pushing me right now. Give me 2 or 3 days to study it, and I'll explain you everything that's happening.
2 or 3 days. Your cognitive load just skyrocketed. So you focus solely on creating solution with your current model, overlooking the possibility it may have become obsolete.
Obsolete.
No, no, the model is not obsolete, Precious. A precious model, yes, is made to last, made to stay with us for a long, long time.
No, it's not obsolete, as I built it in such a way that we can still extend it to add value.
And a model, sorry to say that, but is valid only for a specific problem and a limited period of time. Eventually, it becomes obsolete. No model is inherently extensible. If it appears extensible, it's only by chance. This depends on how the new problem relates to the one you already solved, how well the model is understood, and how mature the business is. Sometimes, to add a new feature, you need to create a different model.
Listen, I know my model, right? I did an event storming, I saw how to integrate this feature in it, and I know it still works.
But the model exploration whirlpool is meant to help discover suitable models, not to trap team in confirmation bias. A model should be challenged, not reused by default. Sometimes you need to depreciate it and shape a new model.
No, we can't start over with a new model every time. We must leverage the work that's already been invested in the design. One does not simply challenge the model. We can't afford not using its power.
But we can't use its power. It's a burden that is holding us down. Stacking change in an existing model without questioning it can only generate accidental design debt.
Accidental design debt, what is this?
So accidental design debt results from decision that inadvertently introduce coupling in models, lower their cohesion and flexibility, increase their complexity, and erode their correctness. And your accidental design debt will manifest as complexity within your model.
Nah, I don't think I have any of these problems.
Have you noticed that it's taking you longer and longer to develop new features?
It's true that stakeholders are constantly on my back because of that.
Have you ever made simple change and had to touch part all over the model?
You did see the last pull request.
Yes, I do. And do bugs pops out in part of the model you didn't even touch?
I mean, I just broke the production that way.
Yeah, these are symptoms showing that your model is resistant to change because it has already accumulated the accidental design debt. Changes became slower and riskier to implement. These are the signs that your model is affected by model entropy.
Model what?
Model entropy. You don't know what it is?
I'm not sure.
OK. So that's the degree of design disorder within a model. The higher the entropy, the less the model is current, consistent, and cohesive, and it loses its ability to produce outcomes without introducing regressions. Design effort is then dissipated on navigating accidental complexity, dealing with unrelated constraints, and resolving side effects. And your cognitive energy gets wasted and isn't effectively turned into business value anymore.
So what you're saying is entropy is dissipating model structure and clarity over time.
Yes. And the consequence is that it degrades the quality of our decision, leading to even more accidental design debt. Business concern eventually becomes so entangled that their boundary disappears and a big ball of mud takes shape. Stacking changes in the model affected by entropy slowly makes it harder and harder to change. Even minor modifications become impossibly expensive and likely to cause unexpected regressions. At this point, you could say your model has sclerosed.
You mean sclerosed as in nothing can be changed without major regressions in the model?
Yes, and that's a clear sign that you're losing control. Sclerosis, then, is locking the model into its big ball of mud shape. Most modernization attempts will fail. Taking back control demands huge efforts.
OK, I understand your diagram here and such, but I don't think it has anything to do with me.
OK, so let's take a look at it at your model. Here, you're trying to address both search and booking two orthogonal problems within the same context. What makes you think they belong to the same bounded context?
Well, simply adding the feature here was quite natural. All I had to do is just add a little Boolean here.
But by solving multiple problems at the same time, they become adherent to each other, creating intrinsic coupling within the model.
Intrinsic coupling? How can a model be coupled to itself?
By merging multiple implicit models inside itself. And what you actually have done has a name. This is the spork effect.
Are you comparing my model with these tools that alternately attempt to take both the role of fork and spoon and completely sucks at either?
Exactly.
So that's insulting.
It usually happens when you are reusing an existing solution to a problem it was not originally designed. And this is the most common form of intrinsic coupling. And by nature, a spork model is fragile. A change required by one of the solved problems may lead to a regression on the other use cases. And over time, the fragile model breaks more and more easily, and you become reluctant to change it because it has become rigid. The only option you have is to stack new elements without touching what already exists. And all those things are increasing the entropy of your model, and therefore your cognitive load.
My cognitive load is fine, thank you.
What you're experiencing is called denial. But just take a look at your model. Because the two models are entangled, you are always spending mental energy trying to sort them out. You need to then to understand a bigger and multi-purpose model for every change you have to make to ensure you won't have regression there. Here, what you need is distinct model for search and booking.
Several implicit models in the same model. So are you saying that microservices is the way?
Well, this is not the way. Will we have this discussion all over again?
Microservices. Good idea. And then we can put the precious model in a shared kernel inside a library. Or even better, in a shared database.
A shared database? Oh, wait, no, not listening.
Who are you talking to?
I don't mind this. So, you're saying that microservices are not the way, so what should we do?
You must unlearn what you have learned. You know, all these developer habits we have, refactoring, KISS, YAGNI, dry, and so on, must be set aside when you shape models.
But I can't afford to challenge my model now, not with all the coming deadlines, and not after all the time I spent refining it.
But the fear of losing the model is the path to the big ball of mud. Fear leads to entropy, entropy leads to sclerosis, and sclerosis leads to suffering. You should train yourself to let go everything you fear to lose.
Let go? No, we can't, Precious. We needs it. We loves it.
But he has some serious points.
But who are you talking to? I think you're under the influence of this unique model. Throw it to the fire. We need to make the implicit models explicit.
We knows the truth, Precious. Only a large language model can save us. So big, so clever, so precious.
A large language model? Oh, I don't want to be a slave anymore. Go away and never come back.
No!
Are you okay?
Dark have been my dreams of late. But no, I'm fine, so how can we prevent accidental design debt?
Let me show you. So when you introduced this change to address the booking in model of the search, you've created here a model tension.
They have tensions now?
Yes, they have. And a model tension is something that is the result of the accidental design debt. And it may induce some interesting coupling within your model.
Okay.
This is a structural stress within a model that signals it's being stretched beyond its conceptual integrity.
And here I guess that conceptual integrity is the opposite of model entropy, right? So given that you gave a definition of entropy, I think that conceptual integrity here will be the degree to which a model maintains clarity, coherence, cohesion.
And its purpose.
So the conceptual integrity will prevent accidental design debt, while our model tensions will erode this conceptual integrity. I see. So It's true that when I added this booked Boolean in the fare of the search, I may have degraded the coherency and the purpose of the search model. But I had to do this, because I implemented the selection the same way before, with a selected Boolean. So if I did it any differently for the booking, I probably would have needed to do a really deep refactoring of the selection.
OK, so without realizing it, you admitted that the previous change was already a model tension on which you built the booking feature. I didn't mention that before, but indeed, in your spork model, you also have entangled an implicit model for the selection. And by adding here a selected Boolean in the fare, you've created a model tension. But since you let this one unresolved, it eventually crystallized. And the tension becomes so entrenched that resolving it would require costly redesign, affecting more business concerns than expected.
OK, so you mean that when a model tension crystallizes, it becomes a structuring constraint of the model?
You mentioned it yourself. It's constrained you in the development of the booking feature. Since the model is constrained, you can no longer ensure its conceptual integrity.
So it means that a crystallized model tension will raise model entropy.
And even worse, they shape model sclerosis since they increase the rigidity of your model.
So to prevent this, we need to do something before they crystallize.
Absolutely. All these are symptoms, for this one, that your model had become obsolete. Spotting a model tension early will allow you to resolve model tension before it crystallizes. So we can use them as signal of accidental design debt. And now you know what you have to do.
Yes, but I don't know if I can do it anymore. I carried this big ball of mud too long.
Then let us be rid of it, for once and for all. I mean, come on. I cannot carry the model for you, but I can carry you.
Wait, what?
Let's review the commit which introduced the selection feature in the search model, because I think it's the root cause of your big ball of mud.
Oh, just say it like this next time.
OK, so here, let's duplicate that. Great.
Yep. So you know my model of the search already. Here was the first iteration where I only added a selection concern inside this model. So to indicate which fare was selected, I simply added a Boolean that says selected or not in each fare, in each ship, in the search. Simple.
Yeah, I can already see there's many model tensions there.
But here? How do you see that?
By using ancient elf magic.
Ancient elf magic. How do you use that?
Quite easy. You simply have to go to the settings, plugins, you look for ancient elf magic, and you simply enable it. And let the magic happen.
Oh, convenient.
That's not a real plugin. OK, so here, you introduce that selected Boolean, thinking it will be easier to implement the selection that way.
Yes.
But you brought here more complexity that you solve. I'm quite sure that the code using that Boolean is quite complex. Can you show me?
Sure, but it's not that bad. So here it's in the search, and for example, here I have a check on whether or not I have a completion in all the fares I have selected.
OK, so that's quite interesting, because as you can see here, you have to loop over all the ships, so stream is kind of for each, and loop over all the fares to find the one that has been selected. That's quite complex. And I'm pretty sure that every concern related to the selection will be that heavy. For example, here, computing the total price. You also loop over all the ships, loop over all the fares, and just to select the fare the user wants to book, you have also to loop over all the ships and loop over all the fares, as you can see here. Here, you have a high friction for low complexity structural tension. The development of a trivial rule requires complex and not straightforward implementation. And why you have that? Because you put the selected state in the wrong place. I will do a little demonstration, if I may. So for now, in your example here, this is the first class of the ship A on the bound outbound that is selected. But what will happen if I'm going to the ship B here, and I'm changing that Boolean selected to true, knowing it's on the same bound?
Yeah, it's not possible, because you can have only a single ship that is selected per bound.
Exactly, but here, structurally, you allow it by adding one Boolean for each of these fares. Here, what you have is an extrinsic state infiltration, which is a structural tension. So that fare cannot ensure the consistency of its selected field without being aware of the selected state of external fares. It should not depend on. This kind of tension usually occurs when the state of external concepts, such as the selection, infiltrates one of its subconcepts, the fare.
Okay. Technically, you could have this problem, but in the real world, there is also code running on it. And so when I select the fare of a ship, I ensure that we keep this consistency. Because first of all, the first thing that I do is that I check the fare that was currently selected, and I set its selected status to false before I can actually set the selected status as true on the new fare. So you see, like, there's no problem. The consistency is fine.
But can't you see exactly the same problem? Here, you have a two-phase transaction in the search to ensure the consistency of the fare internal states, which should have been an atomic operation, because you fragmented the state of what is selected amongst all the fares. And you're so sure about your consistency logic here that I have seen something quite interesting in another part of your code. For example, here, when you check for the completion of that selection, you do some assertion here, and if it's not true, you will raise some exception. What you are asserting is that you will never have more than one outbound selected. What's that?
Okay, it's just some extra safety. It should never happen anyway.
It should never happen. You sure?
Yes.
Why did you write it anyway if it should never happen? Because structurally, your model allows it. So you're not even sure that it might be some case you don't master that can fall into that problem. Furthermore, here...
So wait, what you're saying here is that we should never be able to represent a state of the model that is not valid, but from a structural point of view.
Exactly. So furthermore, here, that logic, checking that in case of one way, you will have at most one outbound selected and no inbound selected, is not a search concern. This is a selection one. You have another kind of tension there. This is the encapsulation of business logic, a diffusion of responsibilities, because the search implements an environment that should belong to the selection. And why you have all these problems, it's because inside your model here, as you can see, you have some fields such as selection complete, total price, and all the selected Boolean. But if I'm changing one of these selected Boolean, what will happen for these two?
Well, we'll have to recompute whether or not the selection is complete and to recompute the total price based on what was selected.
Exactly. So here you have a disseminated representation because you fragmented the state of the selection. So here you have some other state disseminated across multiple concepts that are functionally correlated. And it often indicates the absence of an emergent business concept, which is here the selection. To determine the state of your selection, it requires you to combine multiple sources.
OK, I get your point, and I understand that there are all these tensions in my model. But honestly, it's fine, and it keeps working pretty well here. And I know this because I actually did my exploration phase. I did my event storming. And I made sure that I align my model on what the domain expert actually say. So as you can see here, if I can manage to,
Yeah,
I get it.
It's coming, it's coming.
When a user selects a fare on a ship, we have a ship and a fare that are selected on a given bound. So then we check the completion of the selected fares, and we compute the total price of the selected fares. Select a fare on a ship gives us selected fare. All elements of the model you see here, it's really completely aligned on the language of the domain experts.
But maybe you have overlooked some interesting information in your event storming.
Such as?
So here, you're computing the total price. But which total price you are computing?
I just told you the total price of the selected fare.
OK, OK. And here, you're checking the completion. But you're checking the completion of what?
The completion of the selected fare?
But come on, can't you see that the name of your event here are fare selection from incomplete and fare selection completed? Maybe there is a strong indication there.
No, I don't see it.
OK, so here you have a linguistic tension. It's a salience bias. This is a cognitive bias that reduces people to focus on information that are more prominent or visible. And what is the more visible here is the selected fare. But let's do a little demonstration again. I know that after having implemented that, you added the ancillaries, right? The paid options that are available according to the fare you selected. So you have to list these ancillaries to the user. So the user can select some of these ancillaries, and because there are paid options such as special meals, you have to take them into account in the computation of the total price along with the selected fare. So what total price are you computing? Here, this is the selection. In fact, what you're doing is you're pricing the selection, and at the end, you will have a price selection. If we are going back to the check completion you had, here, once again, you are checking the completion of the selection. You need the selected fare, but it belongs to that aggregate. And at the end, you have incomplete selection and complete selection. Can't you see that all the things here as real model are different states of the selection? No?
I guess so, yeah.
And here, you just squeezed it in the way you wrote your domain event, right? Here you have an implicit lifecycle tension. So you have to be careful about that, because what you need here, according to this lifecycle, is to create a model specific for the selection. Now, how can you do that? It's not quite simple, but you can take in your big ball of mud all the fields required for the selection purpose and make a model out of it specialized for the selection. And here you can see that both search and selection are simpler. But it will not only make simpler here your model, I mean the JSON here, but also your code, which is another expression of your model. Because if you create an aggregate for the selection, all the code you've made for the search will be here less complex and more straightforward. As you can see, selecting a fare, it's something you can do in one statement. Computing total price, you just have to stream over all the fares. And knowing if the selection is complete, once again, straightforward.
OK, I get all your points, and I think I'm starting to understand your logic. So what you mean here is that when I added this invariant here to prevent my bug and to avoid showing the ships that were departing in the past, I added this on the search, which caused a problem on the booking. So I guarded myself against this by checking whether our search had booked ships, because if it does, we don't want this invariant. But in reality, checking if a search had booked ships, I was checking whether this search was actually a booking, and we could see this from the other booking concern that was merged inside of it. So what I should have done instead is remove all the fields or concepts that are dedicated to this booking and move them into a new booking aggregate.
Not remove them, because it might be needed for the search.
Yeah, but move or specialize them in the booking aggregate for the ones that can be. Which means that the booking is more focused on specific concerns, such as the payment mean or whether or not it's finalized, while the search becomes also simpler, because it can externalize them and refocus on the search criteria or the search type. But more interestingly, we can see that what we want to check all along is whether or not the booking is finalized. And to have this notion emerging, we needed to make the concept of booking emerge.
I'm really glad that you realize you need a specific model for the booking. But now, the invariant you added to fix that bug, I need to do the same on my own application.
What do you mean? Why would you need to re-implement that? I feel like you always have to duplicate logic from my service.
Well, since you handle the booking creation in the cruising service, and we manage the post-booking features in our service, I assume it's quite natural that you have the feeling we implement similar behaviors.
Wait, why did you implement these features in the cruising service again?
Because the cruising service was a big ball of mud already.
Or why did you not implement it in the cruising service further?
Yeah, like I said, it was a big ball of mud. And implementing features was taking forever in that service. So our manager decided to create another team to handle important features such as exchange and cancellation in a post-booking service. And since this was a greenfield service, it allowed us to move faster without breaking things.
And I guess that worked really well, because I suppose this is why we keep synchronizing changes between the legacy and your service. Look, as you just pointed, there were multiple domains hiding inside of the search. Namely, we had the booking and the selection. And inside the cruising, we had multiple models hiding in it, including the booking.
And so,
well, you said it yourself, you just have to duplicate the new invariants that I just wrote, right?
yes.
Well, and I can't help but noticing that it's not the first time that you've done that.
But what's your point about that? Because I need to implement the invariant in my exchange aggregate as well, since you can't exchange a booking for a ship that already left.
Okay, I think there is another way of looking at your aggregates here. If I'm not wrong, you also have a constellation, right?
Yes.
So we could just name them exchange booking and console booking. And here we can see these are just representing updates of the state of the booking. And if I remember well, they're quite dependent to the state of the booking in cruising as well, right?
There are. To allow a cancellation, I need to check if the booking was completed on your side, meaning the traveler already took the trip.
Okay, so we are just representing states that the booking can go through as if they were different business concepts. So here, the booking lifecycle actually goes through your service and then back to mine, because the booking can be created and then exchanged and then either cancelled or completed. But also, last time I checked, we also have concepts that are the same exactly on both sides, like the seat preferences. They are represented exactly in the same way. So you see, we even share parts of the model. All these leaks of concept and business logic from my model to yours are actually a strong level of extrinsic coupling, because in reality, they are the fragments of the same model. And that's because we fragmented a single business problem, the booking, into exchange and cancellation, when in reality, we should have only a booking concern. So when you created an outgrowth to work around my sclerosis model, in reality, we were still operating on the same distributed model, which is why we end up with coupling between our services. We work on the same domain flow, we have the same governing constraints, and when the business needs evolves, they evolve in sync. So obviously, our model also ends up evolving in sync to answer these business needs. So your outgrowth actually caused model fragmentation, which also favorizes business logic leaks, which only exacerbates the model.
The problem. OK. So you're saying that extrinsic coupling is the reason we end up distributing every evolution across services. That's maybe why we need to change test and release them together.
Yes, and when they fail together. And they will fail often, given the level of synchronization that is required when releasing them, which makes the model fragile.
I imagine that just like with intrinsic coupling, this fragility will lead to rigidity as well.
Exactly. And in turn, this raises the entropy of the system. And this entropy binds the fragments of our model into a distributed big ball of mud.
Come on, distributed big ball of mud? But my service is a greenfield project, and we follow best practices.
Well, speaking of that, you were supposed to develop faster, right? But you keep duplicating work that I've already done. And also, we've already ended up in a distributed big ball of mud situation, and I can prove you that. So the situation is so bad that even the user experience is affected. Do you remember when I first added the seat preference selection?
Yeah. You expected users to be excited about it. It was a highly anticipated feature. But they were frustrated because they couldn't use it during the exchange on my side. But it's not my fault. I was not even aware I was supposed to develop this.
And that's because the domain expert sees the booking and the exchange as a single flow. So obviously, they thought that implementing the seat selection in the system would make it available everywhere. But this was a business tension, and we completely overlooked that. A business capability discrepancy happens when a capability varies in scope, maturity, or behavior across the system, causing gaps and inconsistencies.
So if I understand that tension, when there is a feature in the booking flow, it doesn't show up in my post-booking flow right away, even though from a business perspective, it's supposed to be a single capability.
Exactly. And I think this is because of the fragmented models that we share.
So all this time, whenever we had discrepancies in our flows, these were signals of extrinsic coupling. Stakeholders expect that once the booking capability is added in the system, it should be available everywhere. But since the life cycle is split between cruising and post-booking, adding the feature in your service means that it only ends up being partially available. So this is a fragmented lifecycle architectural tension, and that was the actual root cause of the business tension we had. So that kind of tension occurs when separate bounded contexts handle different states of the same aggregate while sharing many concepts, personae, and rules, meaning sharing a lot of things related to the ubiquitous language. And it happens especially when you have a lifecycle moving back and forth between services. And I think because of this is why the mobile team need to check the status of the booking. When they need to check the status of the booking, they need to check whether it exists on your system first, and then whether there is an exchange or conciliation in mine.
You see?
They have to look for information all over the place to figure out what is the actual state.
Yes, because you see, the fragmentation got so bad that even other teams are receiving signals of it. And this is a distributed state architectural tension, which happens when understanding the state of a concept requires consolidating data from multiple bounded contexts, which is even worse when they're in different services.
No. OK, it was just a photo. Good. So because the states are distributed, the business logic also ends up distributed as well. That's why I duplicated your invariant. So here I assume.
Yeah, I think we can see these business logic leaks as tension as well. And this happens when behaviors, invariants, life cycle, etc., are scattered across bounded context.
So this leak of logic causes a lot of overhead to make sure we have the same business rules.
And that's a big source of bug, because whenever I change a business rule, I end up breaking something on your system. For example, the ancillaries. When I add restriction on some ancillaries, which are the paid option, right, it strongly impacts your post-booking.
Yes, and I'm urged to align the logic on my side. So I think that frequent breaking changes is maybe also an architectural tension. So it occurs when every model evolution breaks collaborating bounded contexts.
And these frequent breaking changes, they bring another kind of problem again. Do you remember when I added the travel insurance?
Oh, how could I forget? You added the feature so people can book reimbursement travel insurance in cruising, but when they cancel their trip in my post-booking service, it was not taken into account. That was completely useless.
Yes, and people paid for that, so they were not happy. I had to roll back and wait for you to add it to your model. And only once you added it in your model, we could deploy. But then we also had to deploy at the same time, even then. So these architectural tensions, they are forcing us to do releases in sync, which is a process tension. So this means that technical issues are forcing us to adapt our processes. We can see the signal of the coupling even in the way we work. Synchronized releases, they happen when there is a necessity to synchronize heavily around releases and model evolutions across the system. And that's not just a one-time thing. It happens all the time for us.
But there are some ways around this, right? I mean, look, when you added the support for the special meals in the ancillaries, it would have broken my service and blocked your release. But you just used the feature flag to deactivate the feature, and you didn't have to freeze your release while waiting for me. And once I was ready, I toggled that off first. We could just activate it together at once, limiting process overhead and avoiding failures.
But this did not change one thing. The feature was still standing by and producing no value for a long while, even though it was absolutely ready. So in reality, these are just compensatory countermeasures. They don't address the root cause, which is the model fragmentation. So compensatory countermeasures are, for example, when the unresolved design problems are compensated by processes such as multi-versioning, double run, feature flags, and such to limit impact on the team. But one feature flag isn't a smell. But we have 50 feature toggle, and that's a process hell of its own. And I still have to negotiate with you every time I need to add a feature in the end, just to make sure that you will eventually develop something to handle it correctly in your API. Having to negotiate the contract of your interfaces constantly is an organizational signal that the model is fragmented. So contract over negotiation happens when interfaces between systems are heavily negotiated by team. And it's not only about our interfaces. We also end up negotiating every small details of the behaviors of new feature, as it needs to be the same on both sides. And honestly, I always have to fight to make you prioritize it, and it's exhausting.
Always have to fight? You're kidding me. You basically hijack my backlog. Every time you have a new feature, you request development on my side. I don't even have time for a new post-booking feature. Although I suppose these two should have told us that there were an abnormal level of coupling, because you are taking over my backlog, which is an organizational tension.
In a hostile way, on top of it.
Yeah. So this is when the work of a streamlined team is systematically on the critical path of another team.
True, and these endless meetings to negotiate backlogs and defining compatible roadmaps, where's just the system screaming to us, something is wrong, it doesn't have to be this hard. So this inter-team coupling is actually, again, an organizational tension, when teams need to constantly synchronize their plans and priorities despite their scope of autonomy. And you may have experienced this into the form of API planning, for example, but that's only when it's at scale.
And with all this work being tightly coupled, when there's bugs, no one knows to which team they should be assigned. Whenever something happens, the support teams always have to ping us both. So I assume that here we have some kind of unclear ownership tension.
Yeah, especially because it's not just bug. Even the product owners can't agree on who should implement a feature. So unclear ownership happens. It happens whenever there is a need for new feature debugging or development. Debates often break out to determine which team should be in charge, which happens all the time in our case.
So if we step back a bit from what we've seen there, our extrinsic coupling led to frequent between changes between our systems. But also, we had to synchronize releases. And we use some process, such as feature toggles, to buffer the fact that, OK, we need to release at the same time, but we will never be exactly aligned to buffer the fact that the disalignment, and also to buffer the fact that we may break me, right? In my model, I would say. Also, because we have all of this, we had some organizational tensions, so say here the contract over negotiation, because every time you create the feature on your side, you have to toggle it and wait for me to implement on my side, and you negotiate for enabling those toggles together, right? So you have to fight a lot to prioritize things in my backlog. So like I said, here we have different kind of tension. The frequent breaking change was an architectural tension. The synchronized release was a process tension. The feature toggles are a compensatory countermeasure on process tensions. And that compensatory process measure, the feature toggles, were just offsetting problems coming from the process tension and the architecture itself. Just like the contract over negotiation, this is a compensatory organizational measure that was just offsetting here the compensatory process measures. And with all those things, we were never addressing the root cause, that was the extrinsic coupling.
And the worst part with that is that all this compensation end up triggering even more compensation to make up for them. So this turned into a self-fueling compensation system that just keeps stacking compensation and keeps growing until eventually it collapses under its own weight, which is basically organizational entropy.
We were trying to solve problems in wrong places, wasting a lot of energy because we didn't understand the nature of all the tension we had. Because if we take a higher look, we had a business tension, the business discrepancy you described. That was the reflection of an architectural tension. That architectural tension arises from process tension trying to compensate them. And these process tensions were structured by organizational tensions. That's basically the Beipel model. from Jan Bosch. You should take a look at this article, which is quite interesting. But it means that here, all the problem was socio-technical, in fact. Because if we go to the root cause of the problem, when the manager has decided to create a post-booking team, he created here an architectural tension, kind of effect of the Conway's law. And because of that, we created an outgrowth from your model that that creates some extrinsic coupling with a fragmented model of our services. So extrinsic coupling signals are mainly socio-technical.
So this means that when we're using intrinsic coupling, when we have intrinsic coupling, we are using model tension heuristics to detect model tension as signals, which allow us to act before we have model entropy. In the case of extrinsic coupling, since these signals are mainly socio-technical, it means we have to spot them to prevent entropy at the scale of the entire system.
So model tension heuristic can help us prevent accidental design depth. But they are only heuristic, not surefire rules. Because if you take this example of an e-commerce platform, having a cart in a shopping bounded context that becomes an order and then a parcel is not a fragmented life cycle because they may have different persona, don't share a lot of ubiquitous language. So it does not always reflect tension, right? It's heuristics.
And these signals, they can hide pretty much everywhere. So we can look for them in the code, we can look for them in the conversations we have, in the processes, and even in the countermeasures that we use to address the problems.
And you should build a case. Gather all bodies of evidence revolving around the part of the model, the part of the organization, the specific processes, which are in fact part of the socio-technical system.
So once you have a body of evidences, you need to act on this signal. And to do so, it's better to run limited experiments that are safe to fail. This way you can test your heuristics. You can experiment to see whether or not these are actual problem without causing more damage in your system. There is an article about this from Rebecca Worfbrook and Matthias Veres. I encourage you to read it as well. It's pretty much this idea of how do you run limited experiments on this and how do you act whenever you discover this kind of tensions of a signal.
OK, so to sum up, we discovered first that your model was a big ball of mud, and we need to create new models from the search model, which is a spork model, actually.
But it looks kind of hard, so I'm not sure how we can extract the booking in this case.
You can use a really neat process to do that. So here, knowing that everything is coupled within the search, you can start a model mitosis. For one who knows. So here, you will create a new bounded context from the existing one, the booking one, but at the beginning, it may be really entangled with that the search, right? Because it will share a lot of things. So it means that those bounded contexts will have some uncertainty in their boundaries, and this uncertainty, you will contain it in a transitional shared kernel. And as you add more and more complexity within the booking bounded context, that shared kernel will shrink until you can have distinct models. But the problem is that also we fragmented the model between your system and mine. So in fact, once you've done that, I should take that booking model in mine, post-booking service, and in fact create a booking service with a booking model.
OK, so this whole model mitosis that you mentioned looks pretty neat, but it looks pretty hard to do as well. I wish there was a talk to explain
There's
how to
two
do
guys that 2 years ago here gave a talk about that, so it's available on the channel, the YouTube channel of Domain-Driven Design Europe. So that's all for us. Thank you very much. I'm Julien Topc. I'm the CTO of Shodo, consulting company specialized in domain-driven design, and I'm also a socio-technical coach.
And I'm Josian Chevalier. I'm a tech coach at Shodo as well.
You can scan that QR code to have access to our model tension heuristics. There's a few for now, which is documented, but we'll add more. Thank you very much.
Thank you.